Okay, we're on air.
Live.
Hey, everybody. We are here at the Adafruit factory in downtown Manhattan. We do all sorts of design, electronics, and good stuff. I make electronics. You market this electronics. Yeah, but for the next half hour, we're going to see what the community's up to. Did you know that?
I don't do anything else on 7:30 on Wednesdays.
That's right. We're here every 7:30 on Wednesdays Eastern Time to see what the community's up to. We're going to be here till 7:50. We're going to call on some people, mute your mic until we call on you. When we call on you, take 2 minutes to show off your project, and we'll go to the next person. So we have time for everybody. Let's start off with JP.
Mix it up.
Oops, sorry. Is that okay?
Yeah.
You can handle it.
Huh? I'm doing it. All right.
Hey,
everybody. So it's full-on cardboard madness around here, and we were excited last week to see a post that Bunny Wong did about using paperboard or cardboard as a substrate for electronic circuits. And instead of using breadboards, he's soldering stuff straight onto copper tape on cardboard. So I went and took some chunks of copper tape and put them on little bits of cardboard and soldered resistors to them. So I made, this was a little 10K resistor card or board. This one accidentally has one that I shaved off of there. You cut traces anytime you like with this stuff. But there's a 6.8 ohm that I left on there. And then I built a little project using CircuitPython and a Circuit Playground Express, where I just have this little clippy that I can clip resistors into. So this one turns green, so that was the 6.8 ohm, and it goes back to red, and then I can put my 10 ohm, or my 10K rather, in there, and it turns white. So I thought this was kind of a neat way to prototype electronics, or maybe even make a finished little game or a learning experience. It could be a resistor code learning thing, or it could be anything. You could use these as little puzzle pieces. So I know at least one person in our chat was working on a board game, and they said they were going to integrate some of this into the pieces, which sounds pretty cool. Yeah. So I want to share that, and I encourage people to go check out Bunny's blog post. We posted about it on Adafruit blog, so you can find it there. And then tomorrow on my live stream, I'll be doing some crank and slider mechanism stuff using a Circuit Playground Express. So tune in. I won't even run it right now, so you have to anticipate that. Tune in tomorrow at 1 p.m. Pacific time, 4 p.m. Eastern time to John Park's workshop.
You heard that. You got to watch the show.
Okay.
What's going to happen? Next up, Colin. Wait to Colin show up. Sorry. No, to Scott.
Hello.
Sorry. I have them in order here.
Yeah, I know. So I figured I'd do a quick unboxing today, or mailbag is another way to say it. So I've got two things. I've got this thing from Vistaprint, and I've got this thing from Phil.
Well, what's in the boxes?
We'll see. So actually, I know. So the first thing I wanted to show was the Vistaprint is business cards that we did so that we can give them away at PyCon.
Look at that.
So,
ooh.
It looks backwards to me, which was throwing me off.
That looks right.
It's great.
Looks good to you. And then the back has links to the code and the community side. And thanks to Bruce for doing this design. Looks awesome.
The art is in our, if you, on the Circuit newsletter, adafruitdaily.com, we have this art if people want to make their own too.
Awesome. Yeah, so I did those at Vistaprint, got them today. So PyCon is in a week, so it's going to be soon. The other thing I got was from Phil here, and it's a big tube. And I want, you know, the easiest way to get things out of a tube is to shake it.
Yeah.
It's full of gemmas, PyCon gemmas, and a lot, and they're all over the floor. I think there's something else in here, though.
There is.
More gemmas.
More gemmas.
There's just gemmas.
Yeah.
Did you even count how many you sent me?
There's enough.
There's a lot.
There's plenty.
Because we had to, you know, we made them for the swag bags, and we had we made extras. So there was, you know, because you never know.
Lots extra.
It's not ending. How many did you stick in there?
I was gonna send a booth and have a big fan.
I'll have to count.
Grab the gemmas.
Here, I'll open one, or I'll show them off. Should I show the coupon code? Maybe I won't. You have to go to PyCon to see the coupon code.
Okay.
But I will show them off. Let me just break a pencil. Turn in the new bags. So this is what I just poured out. Here's the back of it. So this is just like a regular Gemma, except it's blue and it's got the Python logo. And then that looks the same. And then lastly, I think there's one more thing in here, and this might be hard. because I cut it open. There we go. I have gemmas everywhere.
Python 3 poster.
Python 3 poster.
Amazing.
Yep.
Looks awesome.
Made it
I'm gonna have to put it up. I was talking with Becca because the desk behind me is hers, and I was like, could I put some stuff up on your wall? Because it's behind me when I'm on the stream. So we're in negotiations.
Okay, negotiate away.
All right.
Keep
Thanks a lot.
The drone is going to stop by later, and it's going to rain on top of your house. More gemmas. Okay. Next up, now Pedro.
Hey guys, I wanted to share with you guys some progress. So we've been playing around with our Bantam tools, desktop CNC, and it's got here Circuit Playground Express. If I can bring it over here. And basically what I've been doing is I've been inspired to kind of make some shields for the Circuit Playground. So I got Circuit Playground here. So I got my little CNC milled PCB. It's a double-sided PCB. So I've been experimenting with the process of doing that. So it's just a simple kind of 0.1 inch header spacing. So I can plug in things like a servo. So I got the servo here. We've been doing a lot of cardboard stuff as well. So I put together this sort of scissor mechanism with these 3D printed, I don't know, joint fasteners. So you can do kind of these little extendy arm things. So attaching it to the servo there and just kind of playing around with different mechanisms and seeing what kind of works, see how we can integrate them in future projects. So let's see if this works. Hopefully I got it plugged in right. Whoa, I hit the mic. Yeah, so there we go. So just kind of seeing different methods of mounting a servo to these scissor hinges to make something useful or maybe something more fun. And having this breadboard adapter is really nice. You could fit it on the breadboard, but mostly to kind of plug in these kind of jumper cables to the back there. So it's kind of neat. It's only secured with screws and these washers. And I'll be putting together a guide on how to kind of make your own if you got access to a CNC machine. So that's kind of what we've been working on, and other stuff as well that we talked about this morning on 3D Hangouts. So if you guys want to see some cool 3D printed stuff using different materials and support material, check out this week's 3D Hangout. It was a lot of fun.
All right.
Okay, cool.
Next up,
Okay,
Lewis. Hello, Lewis.
you're outside.
You're outside of your mic.
Yep. Okay, can you hear me okay now?
Yeah, what you got going on?
Okay, so I have here a Circuit Playground. This is not the Express. This is the 32U4 Leonardo-based board. That's for a reason. You all have an issue open about putting WebUSB drivers on the, or having WebUSB library compatibility for the Circuit Playground Express, which would be really cool. And the reason it'll be really, really cool is to do exactly what I'm going to do with this thing right now. So I have on here a modified version of Circuit Playground for MATA, but instead of using a normal serial port, I swapped that out for the WebUSB that's part of Arduino now.
Yeah.
Or I'm sorry, that should work for the 32U4 chip.
Okay.
Yep.
So, so you can see that the lights are sort of blinking, and I'm going to switch here to the web app that I'm using to control this. And
How are you doing it?
okay, so this is the fun part. I wrote a library called WebUSB-serial. WebUSB-serial is basically a Node.js serial port compatibility layer to do things, to basically send bytes back and forth from a web browser as opposed to a Node.js process. Instead of using like RS-232 serial COM, we're using WebUSB. But exact same API, it's JavaScript is pretty easy to just swap these things out without a hard interface. Anyways, what I'll do here is I'm going to switch to presentation mode, I think, screen share. Okay, so I wrote an application called Chirpers, which is basically IoT routing, but in a browser. This might look familiar to anybody that's done Node-RED. I sort of used some of their user interface. And what I did is I used the Johnny 5 library right here, and I wrote just a little shim so that we can get a Playground IO, which is Johnny 5 is a big JavaScript, a popular JavaScript framework for doing robotics. Playground IO is a plugin so that we can do the cool neopixel things and all of that stuff that the Circuit Playground has. But what I've done a little different here is I did a connection of type WebUSB serial, and what you do is when you authorize a device, we can pick out Circuit Playground because that's in the firmware now. So like I said, a modified version of Circuit Playground for MATA. if we connect to that, what we do is all of that Johnny 5 code, we're able to run directly in a browser. So I'm running that, I'm connected. What you can't see here, I'm actually doing a couple of little toggles here to turn the LEDs on and off, the onboard LED. But I'm getting sensor data out of here. You might be able to hear, I'm not sure if you can hear that or not.
Beep, beep.
The little beep beeps, right? That is from the tap sensor. So all of the cool Circuit Playground components we have available in here, via JavaScript. And I'll have all this code up. My modified version of the Circuit Playground for Moda firmware, I've already put on my GitHub. It's Montez Liu is my GitHub user. But we have basically some really simple JavaScript things to do this with. So this doesn't have to be just, I like JavaScript. I know you all like Python quite a bit, but that doesn't really matter. What's really cool is that if you have the WebUSB driver, we could put that in the firmware. And this Sandeep from Arduino did some work to get this stuff working on the ARM chips. So like some of the maker boards that have the SAMD chips can do WebUSB as well. So if we can, or if Adafruit can bridge that gap to make WebUSB available to the Circuit Playground Express, you can go ahead and write in Python, do all of that, but have the web be able to interface the stuff over WebUSB. And it's one way is my WebUSB serial library, but my modified version is Circuit Playground for Moda WebUSB. It wasn't really that much in the way it changes. We're basically just importing WebUSB. Pointing it to a web browser, you don't even necessarily have to do that. As long as your web browser is on a site that's SSL, on a button click, we present the dialog to do a permissions acceptance, and just a couple of things like that. You can start sending bytes back and forth at a high rate to whatever your firmware is. I happen to like JavaScript, so this is all JavaScript.
Thank you so much. This is amazing. I'll send you a sticker, email support at Adafruit, but email PT at Adafruit when you're ready, and we can post about this, and we'll get this going.
Okay, great. Yeah, this has been a lot of fun. Thanks for having me on here.
Thanks, Lewis.
Outstanding.
All right.
The Numworks calculator has WebUSB. We're like, yeah, we're gonna do something with this. Okay. Next, we're gonna go to Daniel. Hello, Daniel.
Lewis, please mute your mic.
Yeah, he's out. Okay, Lewis. Oh, sorry, Daniel.
Daniel.
Back.
You guys got me?
Yeah.
All right, terrific. So this is a 2-in-1. I really want to do some stuff with LoRa, so I can actually do more wireless projects. So this is based off the RFM 900 megahertz module. So I've got a remote, and let me turn on my new shop friend.
Okay.
So this is Roberto from Futurama. So he's a animatronic
Oh, that's great.
lamp. And let's see. I don't know if you...
Oh, yeah, we can hear him.
That's so cute.
All right. So after seeing Phil's LCD OLED eyes, they're not the same OLEDs, but I finally got around to making this because LCD eyes are perfect, but of course it will erase the eyelids.
Oh,
Well, you're working on it.
that's kind of nice.
Yeah.
All right.
Yeah.
That's what happens when I wake up.
Yeah. So just
Outstanding.
something simple to do with LoRa.
The only thing that's missing is as seen on the show and tell sticker. Email support at Adafruit, and we'll send you out a sticker.
I will slap it on there.
All right. Yay. Good work.
Okay.
Next up, Carlos. Hey, Carlos.
Hey, Carlos.
How's it going? Unmute your mic and show us your project.
Hi, guys. Can you hear me?
Yep.
Yeah.
All right, cool. So my son wears AFOs, which is our ankle foot orthos. And I ran into a problem where he wears these, but they don't give him any range of motion. So they limit the way he walks, and he walks almost like a robot because he can't have that ankle movement. So I went to a couple of specialists, and they showed me some options. I didn't like any because they were simple and they didn't have the angle stoppers. So, but what I mean by that is there's a nominal angle that the foot goes to. So dorsiflexion is 20 degrees and plantar flexion is 45. And none of them had that as far as I saw from their catalogs. So what I decided to do was I bought a structure sensor and I scanned his feet. When I scanned his feet, I decided to 3D print the AFOs out of nylon, or I started with PLA, and then I did it out of nylon because it's actually stronger. And these have a string tension where it puts that tension when you walk, and then it releases back to nominal when you step off. And I also added the stoppers, which stops at those degrees that are nominal to the body motion. But then I started researching on the patent section, 377 to be exact, and I actually found the ones that do the exact same thing, and they are called Ultra Flex Adjustable Dynamic Response, or ADR. And they're actually a lot more advanced than this, and I think I'm going to go back to the specialist and tell them, hey, I found these other ones, even though I already have the prototype here.
That's cool.
Outstanding, Carlos. This is one of the best projects, and it's neat that you made it and then found that someone arrived to that with the patent. You're like, okay,
right, yeah,
print cover these. Otherwise, I'm going to print some more.
But this is great in case you ever maybe your kid wants to go to the beach or something. You don't want to damage the really nice ones. You're like, look, you got some temporary orthopedics. You don't have to worry about. You just 3D print another one.
This is great.
Right, yeah, and then these are compression springs, so they're not as strong as the ones I was looking at. They're like 110 pounds rated, so that's actually even better. But I just thought I would show you guys that I actually fully 3D printed an AFO by scanning his feet and doing all that process using Fusion 360.
Cool.
Yay. All right, well, email support@adafruit.com, and if you want 2 stickers, 1 for each, let me know.
Yeah, you want to post this up in the AT Makers community. It's something that they probably really dig.
Drop us an email too if you want us to post about this.
All right, thanks.
Thank you so much. All right, next up, Mohib, what you got going on?
Hey.
Hi, can you hear me all right?
Yep.
Hi, so I recently joined Hologram IO as a software evangelist, and it's kind of tasked with making a vehicle monitoring solution, kind of off-the-shelf DIY. So it's using our Nova module, which is a USB modem. So our SIMs work with pretty much any device, so like the PyComs and all that. But so this USB modem gives me connectivity. And then I just got this cheap scan tool, OBD USB reader. And so it's plugged in here. And originally I started off doing it in Node.js. Actually, Louis, who was just on, trained me in that. But there's just like not a lot of community support on libraries for this. So I switched to Python, which kind of was a big step for me. I haven't done anything in Python before, but I'll share my screen and kind of show how it all works. How do I do that? Let's see. There we go. All right. So I got it set up with Adafruit IO. Can you see my screen all right? All right, so I've got an Adafruit IO dashboard that kind of shows the GPS locations as well as the speed of the vehicle and just kind of a text readout. This is the code. It's pretty straightforward. So it uses our hologram SDK, Python SDK, to grab the location for the nearest cell tower, and then connects over serial to the OBD reader. And in this case, I'm just giving it one command to bring back the speed, and then send that up to the Adafruit IO cloud, which was pretty straightforward and actually really easy to do.
Yay.
Yeah, and I love that the dashboard had the GPS the map view there.
There's a lot that goes into making something simple and useful.
As you know, working at Hologram. This is awesome. Nice work with that. Yeah, sure. We email support Adafruit, and if you have a tutorial somewhere, let us know. We'll post it up.
Yeah.
So it's on Hackster.io.
Oh, great.
Under Hologram. And also one mention, if anyone's interested in doing cellular IoT, our SIM cards work with the Adafruit phone now. If you go to hologram.io/devplan, we'll give you a free SIM and a mega month for free.
Sweet.
That's a deal.
What a deal.
All right.
Nice.
Next up, we're going to go to Techniac. Hello, Techniac.
Hey, welcome back.
Hey, guys. Can you hear me?
Yep.
Yes.
All right. So this is actually a project I've been working on collaboratively with my robotics team for 6 months now, of automating our school's greenhouse system. So we developed this thing called the Green Thumb watering system, and I'm just going to loosen all the screws quickly. It's a very simple build, but it was my first time doing like a real Arduino project. So inside, if you can see, it's an Arduino with an Ethernet shield.
Mm-hmm.
Up here you have the DHT11 temperature humidity, and it's controlling the solenoid. So the idea is we actually made a app using the Cayenne development software. So it works on a mobile app, works on our website, and we have a Chrome app in the works right now that by just clicking water, it will manually send the command to the hydroponics system to water. Or it can automatically water if the greenhouse gets too dry or too humid. Because it's a fake greenhouse, so it doesn't really control the temperature inside too well, so it gets like 200 or 300 degrees sometimes. So this should help regulate the temperature. And we saw in a month of testing a 75% increase in plant life.
Yay! Wow. Nice work.
More thank
plants.
you.
All right.
Good work.
Well, email support@adafruit.com, and you can put it on that box.
Great. Thank you.
Seen on the show until sticker. All right.
Congrats.
We got room for 2 more people, and we have 2 more people. So
Isaac
we're going to go to Orlando and then Isaac.
Okay.
So keep it a couple minutes each, and we can get everybody in.
Hey, Orlando.
Hey, Orlando. Welcome back.
Hello there. Sorry for the radio silence, but PhD life has kept me busy.
Good luck on that.
Cool. But anyway, I've been kind of just working on. I wanted to make a new toy. I was kind of feeling for something different. So I was making a wrist strap with just a couple of buzzers and LEDs. A really simple build, but I was just kind of bored one day sitting in lab, and I didn't really feel like going back to work. So I'll just kind of give you guys an overview. Can you guys see the Eagle screen?
Yep. Yeah.
Yeah. So pretty simple, just an Atmega 328, standard Arduino. So we're kind of hooking that up to an FTDI and having the bootloader pins broken out. And I basically just have a couple of button inputs. One of them is going to be a flashlight, so it's going to turn on a really, really, really bright light. And then also we have power regulation here with the popular MCP 73831. So that handles charging lithium polymer batteries. And I guess the big thing is that I have, it's not really all that big, but it's a little piezo piezo speaker. And essentially what I want this to do is I've always wanted those wrist communicator watches from Power Rangers. So essentially its main function is it's going to play the Power Rangers tone from Mighty Morphin Power Rangers. So do. So that's going to be its primary function. And initially, I'd also programmed it to do Let It Go from Frozen, just because my sister likes that show, so she's gotten me on it as well.
Okay, well, be sure to wear that during your dissertation. When you're done with your defense,
you're gonna get so many projects done because you're gonna procrastinate. So just think of it that way.
The funny story, I'll tell you another time. But I guess a quick synopsis. So I've actually started publishing some of my DIY projects along with my dissertation stuff. And I'll get into that in a couple weeks. So it's actually kind of funny, but we'll talk about that later.
Publish or perish.
Publish. Yeah. All right. Thanks so much, Orlando. If you want to sticker, you know how to get hold of us.
Come back when you get another breath of fresh air.
Yeah. It's a PhD in Power Ranger. Okay, next up, Isaac.
Isaac and his backpack.
Out. Hey, I have some functional 3D printing applications for y'all today.
Really?
Okay.
My zipper broke off. And so like the little strings that are on it broke off, so I can actually pull it. So there's a cool design, I think by Ben Hex, that is just kind of like a 2-part zipper. And you put it around like the metal part of the zipper, and then you click it in space. You can't really see it too well, but you just kind of click it in place, and it's been working really well for me. So that's cool. And then I have a fun chip clip because my chips are always getting stale. So chip clip. So 3D printing can be useful sometimes.
This is good stuff.
And then I have an update with my guitar tuner. Over here, we have my little the little circuit playground, and it's not working yet, but you just kind of pick the pitch that you want to tune here, and then you play the string, and if it's red on the 3 LEDs right here, if it's red, it's flat, and then if it's gonna be blue, it's sharp. So I'm still working on it, but I ended up using the accelerometer to get the frequency values because it's actually turning out to be more accurate than the microphone sensor just because of the vibrations of the guitar. Then also I'll be able to tune in like a louder place. So yeah, doesn't work yet, but we're getting there.
All right.
These are really cool.
Well, look at all the stuff you're learning.
If you want to see on the show and tell stickers, send a note, and you could start printing out a letter opener right now.
I could.
See, you got that coming for you. All right.
Thank you.
Everybody.
We did everything. Thank you, everybody.
All right.
Perfect.
Thank you, thank you, Scott. Thank you, Orlando. Thank you, Neopedra. Thank you, William. Thank you, Liz. Thank you, Isaac. Thank you, Daniel. And thank you, Carlos. We're here every single week, 7:30 p.m. Eastern Standard Time. Thank you for making it the best half an hour every single week for us. Amazing projects this week. Thank you, everybody.
These are amazing. Lots of new people. Thanks, everybody, for showing up.
This is solid.
I mean, I love the returns, but new people are also really great.
Yeah. All right.
Everybody, y'all great.
Bye, everybody.
Bye.